Hi, welcome to the dynamics tutorials. We have a pulley here that has a 5 kilogram mass and it's attached to a 50 kilogram weight. The pulley has a radius of 0.1 meters. We're going to assume that the pulley can be treated as a thin circular disc, and we're going to assume that the mass B can be treated as a particle. The system's going to be released from rest, and we need to find the acceleration of the mass at B. Let's first calculate the moment of inertia of the pulley. For a thin circular disc, the moment of inertia about the center of gravity would be 1/2 m the mass times r squared. So plugging that in, we get 0.0250 kilogram meters squared. We know that the rope has to match the tangential acceleration on this edge of the pulley. The tangential acceleration here is going to be alpha times r. So this tells us that the acceleration of the rope, and therefore the acceleration of the mass at B, has got to be equal to alpha times r. If alpha is negative, then the acceleration of B is positive. If alpha is positive, then the acceleration of B is negative. So even though these two quantities are related, we need to stick a negative sign in here because both of these are going to have opposite signs. Then we can do our sum of moments about A. So our sum of moments about A is going to be equal to the moment of inertia about the center of gravity for the pulley. But we also have this point mass that's moving around with accelerated motion. So we're going to need to add up all of the point masses times all of their accelerations times their perpendicular distances back to A to be able to account for that as well. So this gives us the 50 kilograms times 9.81 from the weight of the point mass. The weight of the pulley goes through point A and it can't contribute anything. The support gives us an AX and a AY. It can't contribute anything. So this is the sole term on the left-hand side of the equation. Looking over here on the right-hand side of the equation, we have our IA that we just calculated times alpha. And then we have this point mass. So if A is going up, which it's not going to go up, but just to figure out the sign. So if A acceleration of B is going up, that's going to cause a negative moment about A. So we're going to say this is equal to negative the mass, 50 kilograms, times the acceleration at B, which will wind up being negative, so it'll be a minus times a minuser. Times the distance, perpendicular distance from this y direction acceleration back to A. So that's going to be our radius of 0.1. Looking at this, we have both alpha and A, so we need to get rid of one or the other. We've got this equation though, so we'll make that substitution in here. That throws another minus sign in here. Solving this for alpha then gives us 93 radians per second squared, and then plugging this in, this gives us an acceleration of B of negative 9.34 meters per second squared. If you don't like solving it this way, the other way to do this is to break it up into two different free body diagrams. So you have the free body diagram for the mass, you have the tension, and then you have the weight from the mass, and then you have your free body diagram of the pulley. And the free body diagram of the pulley, you just have the support forces here, the AX and the AY, the weight going down, and then you have an equal and opposite tension on that edge. Then you just have to set up one equation for this, a sum of forces in the y direction, and then you need to set up one sum of the moments here, so you'd have two equations instead of one, but you could eliminate t out of those two equations. When you do that, that'll basically stick this equation back together here, and then plug this in, and you'll get these same answers. So the way to solve them here, the kind of simpler way where you stick it together as one system, or whether you break it apart, you'll be able to get the same answer. Thanks for watching.